Hello again, ladies and gentlemen. Allow me to welcome you once again to Fuel the Pedal podcast, that one podcast on all things nutrition for cycling and endurance sports. And today is episode 26, and we are talking with Jamie Pugh once again from Liverpool John Moores University about probiotic supplementation for health and performance. Stay tuned. Welcome back to Fuel the Pedal podcast. Thank you so much for being on that side. As usual, I am your host, Gabriel Martins, that Portuguese nutritionist broadcasting from Madrid and bringing you interviews with researchers and other special guests on performance-related nutrition and health, mostly applied to cycling and other endurance sports as well. And today we are putting the spotlight on a topic that I feel it's important to have here on the podcast. But a word of warning though. The reason why I think it's important to talk about probiotic supplementation and gut microbiota here on Fuel the Pedal is not because this is a trendy supplement and now all of a sudden it appears that the intestine is the most popular organ in the human body, and modulating your gut microbiota, if that's even possible in the extent that it is often claimed, provides any benefit. That is definitely not the reason. Otherwise, the title of this episode, instead of being a balanced overview, would have been 10 ways to improve your health and performance by taking probiotics, and Fuel the Pedal is definitely not about that. I'd rather say that my intention in bringing Jamie here is to try and lower the bar a little bit and try and give you an honest approach in a field that is complex and we are barely beginning to grasp the surface. And I know Jamie well, it's his second contribution here on the podcast. We've talked about this before and we both resonate with this modern way of overstating research results, and I'm sure that for many of the questions that I present to Jamie, if there's no data to give a straight answer about, let's say, a certain probiotic strain, you should supplement to reduce the incidence of upper respiratory tract infections, for example. If there's no research to point in that direction, Jamie won't probably give us an obvious exact answer when there is none, unlike popular claims on probiotic supplementation circulating around the internet. And I insist on this idea because I see a lot of exaggeration and misinterpretation around this topic, with influencers and other people who may not be trained in research interpretation usually stating that we should definitely supplement with probiotics to increase our immune system, or eating kefir or other fermented products because they're going to have an extraordinary impact on our gut health, when we probably don't know if that is true yet and in what measure does that happen. And I'm not saying that there are no benefits of probiotic supplementation. There is undeniable growing evidence pointing in that direction, but the idea with this talk with Jamie today is to summarize the research available and to recognize its limitations. So there are just so many variables to consider, and this episode is all about that, to help us realize how complex this area of gut microbiota modulation really is. And I have the utmost trust in Jamie's work and contributions to this field as someone who knows what he's talking about. He was part of the large panel of researchers on the position stand on probiotic supplementation on the Journal of International Society of Sports Nutrition. He's part of one of the most prestigious universities in the world regarding sports nutrition related research, and he's been mentored by some of the best like Dr. James Morton and Dr. Graham Close, who've been here on the podcast before. So I've done enough spoiler already. Let's move straight away to today's episode, probiotic supplementation for health and performance, a balanced overview with Dr. Jamie Pugh, up next on Fuel the Pedal podcast. Jamie Pugh for the second time here on Fuel the Pedal. Haven't you learned last time?
Yeah, I know. I can't believe you've had me back. Thank you very much for the invitation to come back on and talk some more drivel.
It's a pleasure to have you here again, Jamie. It's been, what, a year already?
Something like that, yeah. Time goes. Because I think it was when one of the last studies that we came on, so it would have been something about that.
It was indeed. You had just published a paper precisely, I think, on probiotic supplementation in reduction of the GI symptoms in marathon runners, I think. And we went on to have a great talk about gastrointestinal symptoms in cycling. But regardless of that, how have you been doing these strange times, Jamie?
Yeah, not too bad. We're lucky here, obviously in the UK, that we can still get out and exercise. The weather has been surprisingly good for the last few weeks, so that's been a bit of benefit. And then suppose just like everybody else, having to readjust, find new routine, and adapt and evolve, and carry on like that. We try and make it work somehow.
Adapt and evolve. That's perhaps a good way of putting it. So, Jamie was here on episode 6 talking about minimizing gastrointestinal symptoms in cyclists, which is quite a popular topic here on Feel the Pedal lately. We had Patrick Wilson on a 2-episode interview about the athlete's gut, according to his recent book. And you've done some research with Patrick, right?
Yeah, we published a paper last month, I think, where we were looking at the effects of stress and anxiety. I think we've got a couple more papers lined up and some research going forward. So, yeah, it's always great to reach out and collaborate with people like that.
We just love talking about the gut. I think it's probably the most debated topic here on the podcast.
It's just one of those that it's as Phil will get into, it's central to a lot of things because it obviously plays a lot of different roles. You can look at it from a lot of different angles.
Yeah, it sure is, and today is no exception. We can finally dive into probiotics, but before that, how rude of me, Jamie. I'm not even asking you to present yourself. It's because I assume people already know you from last time. So anyway, Jamie, could you please present yourself to the guests as if you've never been here on the podcast before?
No, yeah, of course. So I'm Jamie Pugh. I'm a postdoctoral researcher at Liverpool John Moores University. That's where I also did my PhD. So I think they've been stuck with me for the last, maybe coming on 6 years, I think this year will be 6 years. And for that time, we've been doing work on probiotics and endurance athletes, other sports as well, and looking at gastrointestinal symptoms. And that's been what we've been looking at as well this last year. So one of the papers we've just had published, and then a follow-on study as well, looking at probiotics and carbohydrate use in endurance athletes. So it's all in that sort of area. And then, of course, being at John Moores, you get to help out in huge range of other studies and all the cool things that go on there.
And Liverpool John Moores University is still winning in guest contribution to this podcast. So 1 more point to LJMU. So another reason to have Jamie here is because Jamie was part of the panel that set the International Society of Sports Nutrition position stand regarding probiotic supplementation that you can check for free on their website. So Jamie has been giving a significant contribution to this particular topic of probiotic supplementation. And Jamie, since I let already slip in the beginning of this episode that I have a skeptical or let's say an enthusiastic contained view, if you will, of the probiotic supplementation, I believe we've already talked about this before bringing you here to the podcast, the exaggeration around this topic. And despite the fact that this area is quite novel, complex, there's still a lot to learn. And all of a sudden, I've said this before, your gut is the most popular organ in the human body, and almost any health condition appears to be attributed to your gut microbiota. And since you do research on this, and you're probably more aware than anyone of the current literature, and how do you feel about this almost panacea-like status attributed to the gut microbiota and probiotics as well? Do you also feel that probiotics have this deified status among people?
Yeah, massively. It's something that I think I was aware of very early on, even in the PhD. I think I'd only been studying this for, let's say, maybe 12 months. And then because it's a very novel area, there's maybe a bit of a lack of perceived experts in sport and exercise science. And somehow very quickly I became someone who people thought was this expert. And I was, someone who's barely begun to look at it. And I think it's because of that. It's so novel and it's so interesting that what people don't know sometimes excites them a little bit. And it wasn't one of the topics that's been rehashed over and over and over. It's something that a lot of people didn't know about. And as you said, it's something now that everyone seems to be connected with everything, which it probably is involved in a lot of different processes in the body, in performance and sport. But how much of a contributing factor, or even if it's the angle which we should be looking at for some of these things, probably isn't the right way. I think if we're going to, it's something I'm sure we'll touch on, but if I was going to consider, I don't know, a supplement or a strategy or a diet, yes, it might have benefits to the microbiome or to the gut or something like that, but that isn't the driving factor why I would recommend it. It's probably going to be because of something else that's more critical. So as you said, it's something that has exploded. Everyone seems to think is a huge deal. It probably is, important, but maybe not this be all and end all.
Yeah, that's exactly how I feel about it as well. So I think it's an important consideration to have in mind before we get into this and to sort of open our minds to the insights that you're going to provide here today. And Jimmy, there are so many preliminary considerations and definitions that I could ask you to provide an initial context for our talk today. And perhaps the best starting point would be to ask you about the complexity of the human gut microbiota and how can it influence several aspects of our nutrition, health, immunity, regardless if we are athletes or not.
Yeah, of course. It's a great question and a good place to start. Before I get into that, I do just want to highlight that, my background isn't in microbiology or immunology and things like this. So a lot of the things that I see and some of the things that we'll talk about are purely from my reading and understanding of things and discussions with other experts and other people who do really lead this research. So, but just from how I see it and, how I understand it. So when we're talking about the microbiome, it tends to live in symbiosis with us. So, it survives along with us and we benefit from it as well. And if we break it down, there are a similar number of bacterial cells as there are human cells within us. So we're almost as much bacteria as we are human cells. But if we then go and look at that from a genome point of view, we're outnumbered maybe up to around 10 to 1. So 10 times more genes encoded for by the bacterial cells than they're encoded for by our human cells. So that just shows some of the maybe more complex tasks that they can perform within the body. In the gastrointestinal tract, we might have up to maybe over around 1,000 different species of bacteria. So when you think about that in itself and, just that, it's a complex ecosystem. It's not this one thing, this, microbiome is sort of a term or one of the terms we throw around, but it's not just a static organ in the body. It's evolving, it's living, it's changing, it's adapting to the environment. And yeah, as you said, it's involved in a lot of processes in the body. So some of the obvious ones, just because of where it's situated in the digestive tract, it's involved in nutrient uptake or vitamin synthesis, energy harvest, but it's also then got roles in things like inflammatory modulation, immune response, and all of those are collectively going to contribute to our overall health. Some of the more recent work has even started to look at how a microbiome can influence our mood, what roles it can play in stress and anxiety, and the complexity in that, because there's so many bacteria. Obviously, it's affected by so many factors. So there are some nice experimental models that show us, for example, if you do take an animal with a particular phenotype, so let's imagine obesity or animals exhibiting anxious behaviors, and you transplant their microbiome to a germ-free animal, that recipient animal will start to develop a similar phenotype. So we know that it plays this causative role. And those are really nice studies showing that. What's not clear is then some of the nuances within that and some of the smaller details, and the work in humans is obviously much more complicated when you can't control all of the environment that you can in an animal. So we know that it has this causative role in a lot of aspects of health, for sure. But trying to understand the complexity of that is then very difficult, even to the point that it's still not universally understood what a healthy microbiome is. All of the most recent meta-analysis or review papers, if you look at them, they will discuss vague commonalities. So they might talk about a resilience to change, or they might talk about being more diverse. But if you go in and want to see if there are certain species or strains or the ratio of the genus within there, all of that is yet to be defined.
It surely is complex, and it's really important, I think, to transmit that notion of complexity. And there are also many terms associated with this logic that might be worth defining for everyone before getting deeper into today's conversation. We are probably not going to mention all of them, but I think it might help listeners to know what these refer to when reading research about this topic in the future. These terms include a microbiota versus microbiome, probiotics, prebiotics, symbiotics, postbiotics, and immunobiotics. Could you please define some of these terms for us?
So the microbiome and the microbiota are usually used especially, in lay terms, quite interchangeably. But so if we want to look at the actual definitions, the microbiota tends to refer to the actual microorganisms, whereas the microbiome is referring to the microorganisms plus the genome. I'm sure what we'll be discussing today is mostly bacteria, and that's what people tend to think of when they use these two terms. But it is also important to remember that this does also include viruses and fungi. But in general, when we talk about the microbiome, the microbiota, at the moment, we're usually only referring to the bacteria. Probiotics, there's a nice World Health Organization definition to help us with this one. So it's live microorganisms which, when administered in adequate amounts, confer a health benefit to the host. And there's quite a few parts of that are obviously quite important and that are maybe even be challenged as well. We'll come on to. So first of all, they have to be live microorganisms administered in adequate amounts. And as you've already touched on, that then rules out some of the maybe functional foods because they might have bacteria there but not in sufficient quantities, and have been shown to confer a health benefit as well, which is obviously important. So these aren't just random bacteria. The bacteria are usually screened by companies, by labs, and look at what genome they sequence for and what roles they can play and things like that. The next interesting one then off the back of that is immune biotics, and this is an area that's been growing and growing. I think it will continue to grow. So these are actually inactivated probiotics, so they're not live. So they're usually heat killed, and then what you still get though is the dead cells maintain some sort of immune benefit or some sort of health benefit when they're consumed. So there's even been a couple of studies in the last year where the heat inactivated bacteria were more beneficial than the live bacteria. I'm not 100% sure why. I think this is something that's constantly evolving, but it's something again that just throws in this nuance and this thing to consider, that so maybe the probiotics don't even need to survive the GI tract. See where that goes in the next few years. And the next one then, I suppose, is, as you say, is the prebiotics. So they're separate in that they're not bacteria. They're just a substance that's selectively used by the bacteria in the GI tract to confer a health benefit. So usually some sort of fermentable carbohydrate or something like that, a dietary fiber, something along that line, that essentially the bugs or the bacteria in the digestive tract will eat and ferment. Last one, symbiotic. Usually just a combination of pro and prebiotics on the thought that the symbiotic will help the probiotic and the microbiome in general thrive.
Jimmy, there is so much stuff we could get into just by taking each one of these definitions, and it's certainly a fascinating subject. But I'll try to aim our discussion towards understanding how the gut microbiota can affect or be affected by our body composition and exercise between sedentary, active, and athletic populations. I believe there is data indicating, for example, that obese individuals have a much different proportion in the ratio of, I think, Firmicutes and Bacteroidetes, the type of bacteria, and when compared to non-obese individuals. So correct me if I'm wrong here, Jimmy, but this might have motivated the fecal transplant studies that aim to impact on the host weight management in some ways. So my question here would really be, is our own resident gut microbiota that affects weight management and body composition, or is it the other way around? Is it the fact that we are overweight and obese that afterwards changes our microbiota?
Yeah, these are some great questions. So if we go back first and look at maybe the difference between athletes and non-athletes. So the first real study in this area was actually carried out by Paul Cotter and Ola O'Sullivan over in Ireland. And what they did is they looked at the difference in microbiome between an elite rugby team and a BMI matched control group. And what they saw was that the rugby players had a much more diverse microbiome, but then it wasn't possible to distinguish whether this was due to increased exercise and fitness, or was it because of differences that they managed to see in the diet? So in general, the rugby players had a higher protein intake. I think they also had a higher fruit and vegetable intake as well. And there's been more and more research being carried out since by other groups that are looking to see if there's an effect of fitness on the microbiome, which there maybe appears to be. But again, it's impossible to distinguish, is this because of improvements in body compositions or changes to habitual diet or any other confounding factor that you will typically get when somebody changes their lifestyle to improve their health. In terms of the weight management and the microbiome or body composition microbiome specifically, it's probably to a degree going to be slightly bidirectional. and very difficult to separate. As I said earlier on, the fecal transplant studies in animals have shown that there is obviously a causative role. If you take the microbiome again from an overweight mouse, for example, put it into a germ-free mouse, you will typically get them displaying that same phenotype. The translation then is obviously more difficult. We know the microbiome will play a role in energy harvest from what we eat. It modulate inflammation, so it could affect not just our weight, but some of the consequences of being overweight. There are even things that are starting to be looked at and considered in these indirect effects that the microbiome have. So if we look at the production of short-chain fatty acids that occurs in the microbiome, some of these short-chain fatty acids can actually affect gut-derived hormones, or they can affect our satiety levels, different parts of the metabolic pathways. So it could be that a more health-associated microbiome is one that is more beneficial in weight management or weight loss. But I tend to think more research is needed. And it comes back to what we said at the beginning. I think there are ways in which you can improve your gut health, quote unquote, that would maybe lead to weight loss. But I don't know if you would be looking at it, both from the same angle. I think you'd be looking to lose weight, and then I think as a consequence, you might then see change to the microbiome.
Yeah, absolutely. I totally understand your point there, Jamie. But my question was also aiming toward understanding if there is such a thing as an optimal, or let's call it a more favorable a gut microbiota composition that could be associated to a certain phenotype or body composition, which I assume that it's extremely difficult to ascertain.
It's difficult, as you said. So you talk about the ratio of the firmicutes and turioids. Even with those two, and like I said, we're talking at a genus level there, which is, groups of bacteria that are very different from each other. Even looking at those ratio, there were some initial studies showing that it might be a higher proportion of firmicutes, but then there have been subsequent studies showing that there's a lower proportion. So even something as at that level of composition has been disputed. And I think what we might see more and more of with the microbiome is that yes, there'll be these assessments in the composition, so what bacteria are there, but moving beyond that to see, well, what actually is the functionality of those bacteria. And I think that may be where some of the more interesting research might be.
Perfect. So just to clarify this for the listeners and to show everyone an example of the complexity and how uncertain things still are and probably are going to remain for a while, for the moment there's no evidence that a particular ratio or genus of bacteria, as you said, can predict or predispose individuals to a certain body composition as often claimed. Is that correct?
Yeah, absolutely. Not that I've seen, and the most recent review articles I think would say something similar.
Terrific. So we are talking about probiotic supplementation, and we're already starting to see the amount of factors that we need to consider before getting into what everyone is probably expecting to hear in this episode regarding the effects of probiotic supplementation on upper respiratory tract infections or even carbohydrate metabolism, which we will get into later on. But first, I'd like to ask you about the effects of a diet alone containing probiotic-rich foods such as kefir, yogurts, or other fermented foods in promoting measurable changes in our gut microbiota when compared to supplementing with certain strains of probiotics. And the reason for me to be asking this is because we often get across random messages on social media of foods that can improve your gut health, whatever that means. And what I'd like to ask you, Jamie, is to try and help us quantify and put things into perspective here on how much our gut microbiota can actually change and or resist change with diet alone versus probiotic supplementation.
Yeah, again, I think that's a great question. And before I get into some of that, I think it's again important to go back to what we've already said. And for me, the changes in the microbiome are maybe inconsequential compared to the changes in clinical markers. So when I'm looking at some of the research, yes, the microbiome data is interesting, but the first place I go to will often be, did they also carry out clinical markers? Because that's where because if you see changes in those, but not necessarily changes in the microbiome data, for whatever reason, maybe it's the technologies or the type of analysis we're doing, that's probably still an important finding. But if we just then look, as I said, so if we just look at the effects of diet, though, on the microbiome, there's been a lot of data for a good few number of years now that have looked at what happens when we drastically alter our diet in one way or the other. This might be completely changing, going from a westernized diet to a Mediterranean diet or a high-fat diet, manipulating the macronutrients, something of that sort. You can measure changes in the microbiome. So we're talking microbiome is measured from a stool sample pretty quickly. So even as I think one study has found as quickly as 24 hours, if you drastically change your diet, you can see measurable changes that fast. And there have been studies that have followed this on, and some of them have had different outcomes, different magnitude of changes. And I think some of that will be because of some of the differences in analytical approaches. So it's not something that I think we can get into too much here. But as I said, when we're talking about the microbiome and measuring the microbiome, there are obviously lots of different ways to do this and lots of different models and analytical processes. So that could account for some of the reasons. But there's actually been some really interesting data that I only saw a couple of weeks ago that came out of Stanford University. And what they actually showed was that the microbiome is resilient. It resists change. And that in their study, they took a group of, I think it was overweight or obese participants. They changed the diet and they lost weight. And what they followed them up for, I think, up to 12 months. And in the first 3 months, I think all the participants were losing weight. And as has been seen in a lot of these compositional studies, there was a change in the microbiome at 3 months. But what was really novel about their study was that they did follow them up for 12 months. At 12 months, the microbiomes had all reverted back to what they were at baseline. So this is something that's, as I said, it was only published a couple of months ago, I think, and it's something that just shows that this is another angle that we need to consider, that yes, we can see these dramatic changes, but maybe we do also need to consider the resilience. Or, as I said, for me personally, if I was going to carry out some research in this area, I would be more interested in the clinical outcomes rather than just the microbiome. If we look at probiotics and prebiotics, it's a difficult one. I think there's less work being done looking at probiotics and prebiotics on the microbiome as this whole measure. They often will look at smaller numbers of specific species or very small, much smaller part of the microbiome. I think the magnitude of change is obviously, as I said, because of that, is a lot smaller. I think that's why they do it. It's, rather than try and look at this whole big change in this ecosystem, which you're not going to see, it makes sense to hone in a little bit and hedge your bets. So probiotics, the biggest sources are, as you said, supplements. But even with supplements, it should point out that the term probiotic can't really be used by a lot of supplements in a lot of countries now, as it's already said, because the term probiotic implies a health benefit. There's a regulation to prevent supplement companies from using the term because there's not enough evidence to show that their specific product would confer such a benefit. So something just to highlight there. You will get, as you said at the start, bacteria in fermented foods, but they will often depend on the starter culture and the conditions and a whole host of other things. I think the results from those studies are as, if not more, varied than probiotic studies. And that's because of what we've already discussed there. What will be in the food is much more variable than in a probiotic.
Yeah, that's kind of the answer I was expecting, because the variation in live bacteria in all these products must be so big that for the moment it might be almost impossible to quantify anything. And this may be also connected to a concept you mentioned, resilience, which I believe that's an important aspect worth developing a little bit more, since our gut microbiota is something that is born with us, and probably fair to say that most of it is established during the earliest moments of our life. Jamie, could we perhaps say that most of our baseline microbiome is resilient to change in the long term?
I think so, yeah, at a certain compositional level, especially. So most of our microbiome is formed in the earliest parts of our life. So that some of the biggest factors will be, were we born by conventional birthing method or by C-section? So you can track those changes all the way through to adulthood, and you can clearly, a lot of studies have done this, distinguish between groups of populations from each group there. Then were you breastfed or formula fed? Were you treated with antibiotics in the early years of life? all of those big factors seem to be carry on through for our entire adulthood. Once you get to, I'm going to get the years wrong here, but something like 3 to 5 years old, something like that, the stability then seems to really kick in. As you said, so at a certain compositional level, once we're at adulthood, it's pretty much there. We'll see these small transient changes, but we'll have this core microbiome that doesn't seem to change.
Alright then, so now that we went through some of the basic notions regarding this topic, we can now get deeper into the research on the effects of probiotic supplementation in the different health and performance related outcomes. But just before getting into these, I would just ask you about the variation in the host's response to probiotic supplementation, which, correct me if I'm wrong here, Jamie, but it appears to be enormous. So is it important to consider the baseline levels of certain strains when supplementing, and what strains of bacteria overall appear to be beneficial, if it's even possible to identify any at this stage?
Yeah, this is great. I think there are a few different things to pick up on this one. So the first one, and the obvious one, is that I don't think probiotics are any different to any other supplement, in that if you choose to supplement, it's then going to be best practice to monitor the changes to see if they've had the desired effect for whatever reason you've chosen to take a probiotic. As I said, I think we would do that with any supplements. The next one then, for the individual variation, there's been some really good studies published in the last couple of years. There were a couple in Cell in 2018 from one of the Israeli research groups. And what these studies have done, which is really nice and really novel, is that they've gone beyond just looking at stool samples, which, as I said, is the typical way that which we would measure the microbiome. For obvious reasons, it's the most easily accessible, non-invasive way to do so. But what this couple of studies, what they did is that they also then took biopsy samples all throughout the digestive tract. So took samples of the luminal space, but then also the mucosal layer as well. And what they were able to show in a lot of these studies is that, yes, a person's indigenous microbiome was associated with colonization of a probiotic supplement. So from there, you think, okay, yes, there is the potential to personalize, or at least rule out maybe responders versus non-responders. The only problem, though, was that these could only be identified from the microbiome of the biopsy samples, not the stool samples. So you'd never be able to tell. The technology currently isn't there to see if someone is going to respond to a probiotic or not, or if it's going to colonize or not. So that's one issue to think about. The other then is what we've already discussed, and this is, does it need to colonize? And so we've already talked about the heat-killed probiotics. So if you look at some of those studies, they've still found benefits in clinical outcomes. So again, I don't think we're at the point where we could predict who would and who wouldn't respond to those types of probiotics. So I think, yes, maybe at some point there could be technologies if we could assess the microbiome higher up in the GI tract non-invasively, we could do this, but I'm not sure how close that is. So I think best practice, as I already said, would just be to decide, is there a need for a probiotic? What's the reason you'd want to take it? And then evaluate its efficacy as best you could.
Yeah, I'm really curious to know more about how that monitoring of probiotic supplementation is performed, and perhaps a good way to understand that would be to get right into your latest research on probiotic supplementation and increased carbohydrate metabolism in trained cyclists, which fits right into the nature of our podcast. So could you go over what you've done here, the main findings, and the possible application this may have for cyclists?
Yeah, cool. Yeah, so this was a bit of a proof of principle study. So there's been in vitro data that's shown that probiotics can affect some of the gastrointestinal cell lining, and we can upregulate some of the transporters for glucose. There's been a couple of studies that have shown that in healthy but non-athletic populations, you can increase the insulin response to a certain amount of glucose consumed. So there are all of these potential mechanisms that, as I was reading, I thought there could be something here. So as I said, so this first study was just to see, could we assess it? So what we did is we took a group of well-trained cyclists, and then in a double-blind crossover design, they supplemented with either the probiotic or a placebo for 4 weeks. They had a 2-week washout period, and then they went on to the other arm of supplementation. There's some data as well that's in very small numbers. So these are often case studies found that just acutely taking a probiotic can do some of the things that we were interested in, so they can upregulate some of these transporters and things like that. So we also got the participants to take one of the probiotics immediately before the exercise trial as well. So they, as I said, so they supplemented for 4 weeks. The participants then, when they're in the lab, they cycled for 2 hours at a moderate intensity, consuming roughly 70 grams per hour. So it was relative to body weight. That was just glucose. And then they also did a short time trial performance at the end of that 2 hours as well. And the main findings from that then were that we saw small to moderate changes in total carbohydrate oxidation. So in the group after they'd taken probiotics, there was an increase in carbohydrate use and a decrease in fat oxidation compared to them when they were on the placebo arm of the trial. As I say, our interest was more in the oxidation of the drink that they consumed. And what we found were statistically significant but very small increases in the amount of the glucose drink they took on. So I think that if we were looking at it in absolute terms, it was, I think, just less or maybe around about 0.1 gram per minute more after the probiotic group, which, as I said, is not a huge increase. So there's the potential there. We didn't register any GI symptoms, which isn't surprising. I don't think there are many studies that have done moderate intensity cycles with that amount of fluid and carbohydrate that have seen high instances of GI distress. But as I said, we reported none whatsoever, so we couldn't see the difference there. Because, again, maybe the intensity wasn't high enough, we did look at markers of GI damage and permeability and inflammation, but we didn't even see increases in those markers pre to post exercise. So it was impossible to then see would probiotics infer some sort of protective effect there.
Thanks for that, Jamie. I just have two questions that popped into my mind after hearing you. One of them is, why did you choose to supplement with these particular strains? And I'll include the link for Jamie's publication so you can check it in more detail. And the other question is an applied question to cycling racing, which involves a much glycolytic and carbohydrate-dependent metabolism, if you will. There's more carbohydrate ingested per hour. There's potentially more damage to the gut lining. So do you believe that in this context, we could extrapolate and say that supplementing with probiotics during such conditions can be more beneficial or could be more beneficial?
Yeah, okay. So from a pure practical point of view, the reason we chose those strains, complete honesty and transparency here, is because they were the strains produced by the company that sponsored the PhD. But when designing all these studies, we've had in mind what their previous research has shown with these strains. So they've shown benefits for things such as gut symptoms and gut distress, and they've been used in Ironman triathlons, other large endurance events. So it was on that basis we thought, okay, well, if they've shown benefits in these races where people do take on a lot of carbohydrates, could this be one of the mechanisms? So that's where we sort of went with that. In terms of the practicality of it, if I'm being completely honest, I think it's something that you could consider, but it honestly wouldn't be my first port of call. There'd be quite a few other things that, as a practitioner, I would be checking off the list first to try and reduce symptoms. As when we talked about the marathon study that we published last year, a couple of years ago, as I said, yes, we see reductions in GI distress when people are consuming large amounts of carbohydrates, and you get these episodes or these symptoms of gut distress, as says, or the urge to vomit or the urge to defecate, something like that. But these effects are small, and we didn't really see a huge reduction in the incidence either. So the same amount of people maybe reported symptoms, it's just that they reported slightly less severe symptoms. So if you're not already introducing some sort of formal gut training in the build up to a race, I don't think, probiotics, yes, there doesn't appear to be many negative side effects. There's not been any reported side effects in most healthy individuals, but it's not going to be the cure-all, I don't think.
I love this. I think it's so important to give answers like this, and you probably noticed that I did this question on purpose when I used the word extrapolation, because we often see one study using a particular supplement with positive results in a lab setting, and immediately we start flashing that one study and go on applying that strategy straight away on another completely different setting. And most of the times, as you said, not knowing that there are other basic things to nail before that. So I think that if we're not trained to interpret research, we can't just go on flashing out a study on Twitter just to be first. And I'm saying this to the first author of the study, and I'm sure you're probably the first one to recognize the current limitations of it.
100%. I think it's something that goes on quite a lot, that you see a positive study and then that supplement is deemed good, in broad terms, and then you see the opposite. You see a supplement that has null findings and all of a sudden it's useless or a bad supplement. When the reality is that, no, your study's just shown that this supplement can or can't do this one specific thing that you've researched in the conditions that you've looked at it. And as I said, if the methodology isn't quite right or if it doesn't mimic what you're doing, then it's not to say that it will or won't work when you take it out into the field. And as I said, I was working with a marathon runner in the build up to a couple of major marathons over the last year that had gastrointestinal distress during the race, is really struggling to consume any form of fluid or carbohydrate in the last stages of the race. And even though I've done this research and we've looked at the probiotics, it wasn't until we'd ruled out a lot of other things. Well, actually, we didn't even use probiotics with this marathon runner because it got to the stage that we, again, quote unquote, fixed the issue, and we got to the bottom of the cause of it, and we built strategies around what we were going to do to attenuate that issue, which we managed to do. As I said, the easiest thing, not but the wrong thing to have been, which has been, okay, let's just throw a probiotic at it.
Sure thing, and to nail the basics first regarding the occurrence of GI symptoms before going straight away to probiotic supplementation is crucial, and Jamie himself has talked about this back on episode 6 of the podcast, and Patrick Wilson gave a really nice overview as well back on episode 23 and 24 in case you want to check this out. So another really, really important point that is crucial in all this conversation today is how to take probiotics and when to take them. So could you tell us in which particular situations in athletes might be justified to take probiotics, and in what quantities of colony-forming units and strains should we consider?
Yeah, this is one of those areas that is then one of the most frustrating with all of the probiotic research, in that saying probiotics isn't the same as saying, I don't know, let's say, for example, vitamin D. Probiotics is just a blanket term for all of these bacteria, like you've already said. And then when you look at commercial products, you can have, let's say at the one end where you've got yogurts that contain an undisclosed amount of bacteria, or they may be in the millions, which is, a very low dose. If you then start to look at what I'd say the bottom end of the true probiotic products, you might be looking at something like a Yakult, which has got, I think it's 7 to 9 billion colony forming units, which is just the unit in which we measure it, the quantity of a single strain. So there's only one type of bacteria in there. If you go through the scale then and you look at the other extreme end of commercial products, there are powders out there that have 450 billion. So what's that? I think a lot more. And they could have up to 10 different strains of bacteria. So there's a huge range already in the type of products that are out there. When it comes to deciding which one you're going to choose, one of the first and foremost factors, and this is something that I've had discussions with a lot of different practitioners and people who know a lot more about this area than me. But the first one is again, as with any supplement, is it informed sport tested, or has it been tested to some degree? There's been a lot of confusion in this area because people will tend to think, oh, it's bacteria, so it must be pharmaceutical grade, or you hear these terms thrown around quite a lot, when that actually isn't a universal term. It's not a clear definition. It's not a certified term or anything like that. It's just this vague thing. When actually, the cultures could be made in a facility where other supplements are being made. So there is, in a lot of instances, just a higher risk of cross-contamination as there is with any other supplement. So if you go down that route, all of a sudden you're very limited in the number of probiotics you could consider, because I think there are, I don't know what it is, I think there may be 3 or 4 at the minute. There could be more. I can't remember the last time I checked. Products registered on Informed Sport. So that makes it very difficult for an athlete. Where I would be leaning towards then is which ones have some research in. There are quite a lot of products that have no research for their efficacy as a product. And what I mean by that is that some of the bacterial strains might have been researched and they might have been shown to survive the gastrointestinal tract, or they can survive the stomach, or they can survive bile acids. So, they will to some degree be delivered to the small intestine. But as a product themselves against a clinical outcome, a lot of these products actually have no studies, no human trials in them whatsoever. So I would be looking, first of all, well, does it have any research whatsoever? If I didn't have the sort of shackles of informed sport, if you like, what I would actually be doing is, rather than just thinking, okay, well, I'll take a probiotic because it's a cover-all, or just in case, I would go back to think, okay, what do I want to take this probiotic for? Do I want to take it to reduce my risk of infection or illness over the winter period? Do I want to take it for international travel to reduce the risk of traveller's diarrhea? Do I want to take it to reduce gastrointestinal symptoms? I would then go specifically and find the probiotics that have been used and been found to be beneficial in those outcomes. And I don't think there's a UK or European-based one yet, but there are a couple of good websites from the US and Canada that have these databases of these of commercial product, and they have there you can filter by clinical outcome or clinical measure to see which products have been shown to have a benefit in that. So that's, the species tend to be quite similar. They're often bifidobacterium or lactobacillus, but then the strains can be quite different. So it's difficult to put a finger on one because of all of those reasons. I know that's not a great answer because it doesn't. I think people often, okay, well, which one shall I take? But it's not. It's often not as simple as that.
Not at all, Jamie. As we've said before, I believe overall we need to get used to answers like this, because when we ask about a specific supplement, what we want to hear is a simple answer. It's this and that strain in this specific quantity. But if we don't feel there is enough data, then it's not even ethical from our part to jump into conclusions, I think. So moving on to the area that probably has the most promising effect associated with probiotic supplementation, and it may be of more interest to the listeners, is the effect on the incidence of upper respiratory tract infections. So please, Jamie, what does the current research tell us about this?
Yeah, that's a good point. I think this is where, as you said, a lot of the probiotic research really started, especially in athletes, started to flourish a little bit and really take a foothold. So I've no doubt in athletic populations, this is where the majority of research has been done. And it does appear that, again, we could discuss how big of an effect it is, but in general, probiotics do seem to be beneficial in attenuating upper respiratory tract infections in athletes. Whether they reduce the incidence of infections, so how many instances there would be, or the duration, I think is up for debate. There are some studies that show, yes, you do get a reduction in the incidence of upper respiratory tract infections. I think the majority of research actually shows that you get a reduction in the severity or the number of days sick, which is still quite an important thing. If you have an athlete that can return to play a lot quicker or has fewer days off ill, that's obviously going to be beneficial. In terms of the strains and the quantities, again, it's difficult. So I think from the JSSM paper, I think we highlighted about 22 studies that had looked at the effect of probiotics in some ways on upper respiratory tract infections. I think 14 of those found a benefit of some sort, whereas 8 had a null finding. Even of those 14, I haven't got the exact number, but there weren't many studies that were replication studies, or that studies that had found, that had used the same probiotic product more than once. I think in the studies where they have used the same probiotic, I think there's even been conflicting results. So, one product might have fallen in that 14, but also fallen in that 8 where there was no effect. So it's a difficult one to do. The general consensus, so the British Journal of Sports Medicine in their consensus of a few years ago now, their suggestion was that it was a probiotic that was potentially a multi-strain product. So they appear to be more beneficial than a single strain that contained specifically lactobacillus and that had at least 20 billion colony-forming units. So that's, as I said, it's quite a vague recommendation. Mine would be to go and see what was the specific product that was used in some of these studies. And as I said, there's been some great studies by Nick West and David Piner and researchers like that. I would go and see which one, and you could maybe go in one step further and see not just which one was beneficial, but which one had the largest effect size as well.
So let's see if I understood correctly. For the moment, it's wiser to read the studies and check what brands were used for that particular study, rather than simply looking for research on particular strains. Is that correct?
Yeah, absolutely. And I said, I know again, it's more hassle, it's more difficult because it takes a bit of work, and you can get bogged down in some of the bacterial, the species and the strain name and stuff like that. But as you said, even if you can't find the commercial product name in the paper, if you just copy and paste the species and the strain and you Google it, you will find the commercial product pretty quickly.
Right, so we are approaching the end of this episode, and it's probably a repetition to ask you about the effects of probiotic supplementation in reducing gastrointestinal symptoms during intense endurance exercise, since you already talked about it on episode 6 and when talking about your latest research with cyclists. But I think it's inevitable to include it here in today's set of questions. So, Jamie, could you briefly go over this again?
Yeah, I think there's some evidence there. I think, again, it's a very small effect, if any. There are certainly a lot fewer studies looking at this and some of these areas than there are that have looked at the effect of immune function. So there's a paper by a researcher called Shing that I know Neil Walsh was one of the researchers on. Justin Roberts has done a couple of studies in this area, and then obviously the studies that we've done ourselves. If you first of all take the effect of just gastrointestinal symptoms, which I think would be the outcome that most people would be interested in, there seems to be a small but consistent effect with some of the probiotics in reducing the severity of symptoms. When it comes to then, I said, a broader term of GI health or markers of damage and things like that, the picture's a lot less clear. One of the big reasons for this is that these measures can be quite variable. You see a huge range of values between participants. You've only got to go look at some of the graphs on our marathon paper or in Justin Roberts's Ironman triathlon paper to see that you can get some people who, from these indirect markers, as I said, because we're usually talking about a blood marker as an indirect marker of damage in the gut, you can see some participants with next to no change at the end of exercise, and some that huge changes. Similar, there was a study with Asker Eukendrup in, again, Ironman triathletes that found that you get this increase in damage, or maybe what we call bacterial translocation, so bacteria moving across into circulation. But the changes, again, are quite small, even after an Ironman. And whether they're related to GI stress is up for debate a little bit. They found a very weak correlation between gut stress and markers of inflammation. In all of the studies that we've done, we've never seen any relationship between these markers. I think there are probably other supplements that have been more effective in reducing these markers if like I said, you indeed wanted to reduce some of these markers anyway. But I think there's some argument that you could take a probiotic to reduce the incidence of distress. I'm not sure how effective at the minute we know they are at reducing these markers of damage.
Jamie, just before wrapping up here, I just wanted to get your opinion on a study that came up last year regarding the overconsumption of dietary protein and the possible negative effects this might have on the gut microbiota. I think it's quite clear now that for most athletes, including endurance athletes, benefit from a high protein diet approach. But in some ways, I feel that protein came from being totally forgotten to now being almost deified, if you will. So, do you believe that there might be any negative consequences of consuming a high-protein diet for athletes' gut microbiota, and what mechanisms or interaction could there be between dietary protein ingestion and our own gut microbiota?
I think there's a potential, as you said, there's certainly a mechanism by which if you oversupply dietary protein, you're going to deliver more protein to the large intestine, as I said, which is where we hold most of our microbiome. As I said, so the majority of the protein we take, if it's easily digestible, will be absorbed in the small intestine. The more we eat, the more we'll likely get to the large intestine. What you then get is you get this what we call competitive fermentation of whatever's there. So the bacteria that are most likely to thrive are the ones that have an adequate food supply. If you like, so if we put more protein in there, bacteria that favour fermentation of proteins will thrive. The flip side, if we eat more fibre or more carbohydrates, more fat. So there is a potential mechanism why that can happen. I think the the problem we've got is that there are too many other variables within this which make it difficult to give a recommendation. So because we could be looking at, in some of these protein studies, it's what are the sources of protein that they're coming from. If they're coming from processed meats, then there are probably other ingredients within that separate from protein, which could be more harmful. I personally don't think there's the data there yet to say that if these large amounts of 2 grams per kilo a day is detrimental. And as we said right at the start, I think when you put it in the larger picture, I would also then just be more interested in how much fruit and veg do you consume in a day as well. And so as a consequence, how much dietary fiber are you getting? Because ultimately, all of these things balance out, and we could find, these studies might show that yes, there's the potential for high protein to cause damage or to be harmful to the microbiome. But if that effect is smaller than the effect of dietary fiber, which could be beneficial, then the net is still, again, quote unquote, healthy microbiome.
Love it. And there we go again with the tendency to oversimplify things and forget that we eat a variety of foods that can interact differently. So it's really difficult and unfair, if you like, to point any fingers when looking for culprits for a specific disease or a specific condition. So let's move on to wrap up here, Jamie. What take-home messages would you like to leave us with regarding this subject?
Yeah, absolutely. I think the first thing, as I said, is to consider what is the reason, what is the outcome that you would be looking to take a probiotic. So are you about to commit to the winter period where we know you're going to be at a higher risk of some sort of infection, getting ill? So therefore, we might be thinking, okay, well, I'll take a probiotic to maintain immune function. You might be, on the flip side, peak race season, traveling all across Europe, in which case the biggest thing might be, okay, well, I'm going to reduce my risk of traveller's diarrhea or something like that. So it would, again, the same as any other supplement, what is the reason that you want to take it? It's no point just thinking, I want to take a probiotic to be healthy. There should be an outcome that you're trying to improve in some way. Once you know what that outcome is, I would then go and see which probiotics have been beneficial for that particular reason, and really then try and replicate what they might have done in that study. So what was the dosage that they used? How long did they supplement with it? And just constantly reassess. There's some reports in studies, we never really found it in our studies, or not that anyone reported it, that initially once you take some of the probiotics, in the first 2 weeks, you might get a slight increase in GI symptoms. That I know that's been reported in, especially some of the Australian papers. As I said, it's not something that we've ever seen in our papers, but it's just something to be aware of. And like I said, you should then just be doing this constant reevaluation. Hopefully that's reasonable enough takeaway from that.
Fantastic. And regarding this topic, since you, throughout this episode, I believe you were able to really recognize, the current limitations of probiotic supplementation and the complexity of the gut microbiome, what research would you like to see performed in the next 10 years?
Yeah, I think there's so much that needs to be done in this area. One of the first would be really nice to get back to basics with some of these studies and look at simple studies like a dose response. As I said, when you're looking at products that go from 9 billion to 450 billion, there's not often a rhyme or reason. It might be commercial, it might be manufacturing capabilities, and yes, some of these doses have been seen to be beneficial, but the optimal dose could be much lower or much higher. So I'd love to see some of those studies done where we see what is the optimal dose to take. We're guilty of it in our studies that we haven't done this type of work. We've just given a dose that was used in previous studies that we know was beneficial in other outcomes. The next one then would be to see almost a little, probiotic on probiotic study. Again, hands up, we've done it. We use one product and compare it to a placebo. The best thing to do would surely to have more studies where we're comparing different strains, either individually or different formulations of products and different commercial products, to see which would better answer some of the things that we've talked about here, so that if I wanted to improve a particular outcome, actually have seen in one study that 2, 3, 4 probiotic products were used, and this was how beneficial each of them were compared to the others. Those are some of the real basic studies that we've done that I think need doing for probiotics. For microbiome in general, I know that there are different technologies being produced, and hopefully some of this stuff will be started to see in the next few years. But everything that I look at, and as I said before, think about when I think of the microbiome, comes back to that cell study in 2018 for me, where at the minute we take these microbiome measures from a stool sample, yet it's not a great indication of the microbiome. So if we could start to non-invasively measure the microbiome throughout the digestive tract, I think that could be a huge breakthrough in research. And I know that there are different researchers working on technologies. So that, as for the microbiome side of things, I think would be huge.
Terrific. So I think there are some really important messages for the listeners to consider, especially regarding the limitations that we still have, and also to some researchers that might be out there if you want to engage into this area and fill in the gaps on what is yet left to be done. Jimmy, if people want to get in touch with you or keep up with your social media interaction, where can people go?
Yeah, the best place is usually on Twitter. So I think I'm at Pugh_Jamie, and then all of the usual places, LinkedIn. They can find my email on the Liverpool John Moores website. It's just j.pugh@ljmu.ac.uk. All the usual places.
I don't usually make comments about this, but Twitter is such a powerful tool, isn't it?
It's one of the, and maybe it shouldn't be, but it's one of my biggest resources for new research, especially research that's outside my usual, bubble, if you like. I think it's a fantastic result. I think if people do follow me, they'll get bored pretty quickly. I don't tweet an awful lot, but I do tend to retweet a lot of the content that I see, because there is some really good things out there.
It surely is a good tool to use, but yet again, as with any other social media platform, you really need to know who to follow, which is a problem we are faced with nowadays. Jamie, this has been terrific and really informative, especially in helping everyone understand, I think, the complexity of this issue and the limitations of it, sort of like coming down to earth again and have a balanced overview of the research on probiotics and what's left to be done. Jamie, thanks so much for your time, and I hope you enjoyed your second visit to Fuel the Pedal.
No, it is great to be back. Thank you very much for the invitation to come on, and I know I've gone on and waffled a little bit there, but hopefully there's some takeaways there for people. And as I said, if people got questions, or the same thing, if I've said something and someone disagrees, then even better. I would love to be pointed in the right direction of other research that I've not come across.
Healthy discussions in science are always welcomed. So, Jamie, thank you so much for your time, and I hope to talk to you soon.
Great stuff. Take care. Speak to you soon.
And it's done for today. Thank you for staying until the very end of this episode and to be on that side. New episodes are coming now as things progressively get back to normal. So stay tuned to Fuel the Pedal podcast. Stay home. Stay safe out there, guys. Cheers.